Hi there, in this lesson we're going to be looking at graphing hyperbolas. And really hyperbolas have many of the same features as some of our other conic sections. We'll be talking about centers and foci and vertices and all that kind of stuff. So everything that we've dealt with in terms of parabolas and circles and ellipses, a little bit of everything is kind of thrown into these, all right? When we approach these, it's very similar to the way that we graph the ellipse. But with the ellipse, we had a major and a minor axis. Now we're going to have a transverse and a conjugate axis. And we treat these almost the same way. The reason we don't refer to them as major and minor, why we've gone to transverse and conjugate, is major and minor implies that one has to be larger than the other. And that's true. The major axis has to be larger than the minor axis. But with transverse and conjugate, that's not true. The transverse axis can be bigger or smaller than the conjugate axis. And likewise, the conjugate axis could be the bigger or the smaller one. Okay, so we're not locked into that same kind of thing. Now, just like with the ellipse, the order of these is very important. The order of the ellipse was determined by which of those values is bigger. Here, the order is determined by the minus sign. So the transverse axis kind of acts like our major axis, except it doesn't necessarily have to be longer. But it's basically the segment whose endpoints are the vertices. And that's important, that the endpoints of this thing are the vertices, just because when we go to graph this thing, as soon as we go to graph our transverse axis, we're going to find that we already have it graphed. And really, it just confirms where our vertices are supposed to be. The conjugate axis is just a segment that's perpendicular to the transverse axis, so it runs in the other direction, just like our major and minor did. It passes through the center. Again, just like our major and minor did. And the conjugate axis is just there to help us establish the asymptotes. Okay? It's going to help us graph those asymptotes so that I can draw the graph of this thing. And those asymptotes are basically going to do 90% of the graphing for us, determines the width of these and everything. All right? So let's get into one of these problems. And hopefully you have your formula sheet handy with you. But as I look at this one, this is in my standard form for a hyperbola. So the first thing I'm going to do is decide if this thing is vertical or horizontal. And really, it's just determined by whichever value comes first. This time, the x value shows up first, which means this one is horizontal. Okay, so I'm going to put a little label here that this one is horizontal. And so now I'm going to identify the center. I can see my h value right here and my k value. Remember, the h is always with the x and the k is always with the y. So my center this time is 1, -2. And now I go to the vertices, and if I look on this thing, my vertices, it says right there on my formula sheet, this is going to be h plus or minus a, comma k. And I know what h is. H is the 1 plus or minus a. Well, right here, this is a squared according to my formula sheet. So if 25 is a squared, it means my a value is like 5. And I just take the square root to get that. My k value, I already know, that's a -2. This comes right from my center. And now I start doing a little bit of addition. Really, this is signifying that I have two ordered pairs here. I'm going to do the 1 plus 5, which is a 6, comma -2. And then I'm going to do the 1 minus 5, which is a -4, comma -2. All right? So I get two vertices here, one at 6, -2, and the other one at -4, -2. Okay? And now I'm going to deal with the foci, and right again on my formula sheet, I look at foci, and I see that it says h plus or minus c, comma k. So this time I have my h value, which my h value again is 1. My k value, which is -2. The thing that I don't have here is the c value, all right? But once again, on my formula sheet, I'm given a little formula here. Section this off. But I'm given this formula. It says that c squared equals a squared plus b squared. This time it's just my Pythagorean theorem. Unlike the ellipse where we had a minus sign here. But I basically have everything I need. The a squared we already decided was right here. It was this 25 that's up here. So my a squared is the 25. The b squared is right here. According to my formula sheet, that second denominator is my b squared. That's the 16. And now when I add these two guys together, that's going to give me a 41. And now I take the square root of each side. And the square root of 41, I'm just going to estimate this on a calculator. Looks like for this one, it gives me about a 6.4. And so now I come back up here. This is a 6.4. So I do 1 plus 6.4 is a 7.4, comma -2. And then I do the 1 minus the 6.4. gives me a negative 5.4, comma, negative 2. And so those are my two foci. And the first thing you notice here as I write these down is when you look at all these values, out of all the ordered pairs that I've written down, you'll notice that the y value is the same for every single one of these. And typically when I do this, I'll fill out the y value all at once. As soon as I know this thing is horizontal, I'll fill all those out at once. Okay? So again, you know, half of all of my ordered pairs are the same thing, so it makes it really easy. The transverse axis I treat the same way as the conjugate axis. So once again, coming back up here, a squared is a 25, which means my a value is just 5, which means my transverse axis is 10. It's 2 times that value. A is like the radius. The transverse axis itself is like a diameter. And it's the same thing here. My b squared is the 16, which means my b value is actually a 4, which means my conjugate axis is going to be 8. All right? And so now when I go to graph this thing, here's what I'm going to do. I'm going to plot all of these ordered pairs. So as I look down across this, I think I can still go by ones here. So 1, negative 2. So 1, negative 2 is right here. And then I've got 6, negative 2. So this thing is just going to fit. I've got negative 4, negative 2 is right here. I've got the 7.4, negative 2 is right here. I've got the negative 5.4, negative 2, which is right there. And now my transverse and conjugate axis, the transverse axis, because this is a horizontal hyperbola, my transverse axis is going to be horizontal. It always follows the direction of the hyperbola, which means I want to count 5 in each direction. And if I show that from the center, if I count 5, 1, 2, 3, 4, 5, I end up at my vertex. And the same thing in the other direction, 1, 2, 3, 4, 5. And really, I should end up at my vertex. That's the definition of the transverse axis. Its endpoints are on the vertices. So if I've already got my transverse axis plotted, it's my vertex, or my vertices. The conjugate axis is now going to be vertical. It's going to go in the other direction. So I'm going to count up 4, 1, 2, 3, 4, and just put a little mark. Down 4, 1, 2, 3, 4. And just like the ellipse, I've got these 4 points that I'm going to use, these 4 right here. But instead of drawing an ellipse around these things, instead I'm going to draw a box around those 4 values. Okay? And when I draw this box, I'm going to use a dotted line. So I do a dotted line here, making a box, which is even easier than drawing an ellipse. So I make this box. And then from here, to draw my hyperbola, I'm going to just connect the corners of this box. I'm going to draw a diagonal line. It's going to go through the center and through the corners of my box. I'm going to do the same thing going the other way. So I draw this diagonal line that goes through the center and through the corners of my box. Those are my asymptotes. Okay? And now to draw this thing, I essentially have what looks like 2 parabolas facing in different directions. The parabola starts at the vertex, which is this point right here. So I'm going to start at that vertex. And I know how asymptotes work. I'm just going to hug that line. I'm going to draw a curve that hugs the line. And I do the same thing for the vertex on the other side. I've got this vertex right here. I'm just going to start at the vertex and draw a curve that hugs the line. And that's it. That's my hyperbola. Okay? So I use the transverse and conjugate axis to draw what I call a magic box. And once I draw that magic box, I have my asymptotes, and my graph kind of takes care of itself. Okay? If I look at another one. If I look at this one. All right? When I first look at this one, I can see that the y value shows up first. So this one is going to be vertical. So I know this one is vertical. The center then, I can see that with my y value, I've got the 3. So that's the y value for my center. And then the x value is negative 4. So it's negative 4, 3. Again, x is with x and y is with y. The vertices this time, as well as the foci, last time my y value stayed the same the whole time. If I look down through my formula sheet, this time I'm going to see that the x value stays the same for every single one of these things. All right? Every single one. For my vertices, it says h comma k plus 1 over, k plus or minus a. And I know the h value is negative 4. K is the 3. And then my a value, well, right here, this is a squared, which means my a value is 10. So I'm going to do 3 plus 10, which gives me a 13. I'll put it right down here on the line. I do 3 minus 10, which is going to give me a negative 7, which I put right down here. So now I have my vertices. The focus or the foci here says h comma k plus or minus c. So I have negative 4, which I already wrote down. K is the 3 plus or minus c. I just need to find my c value. Well, again, c squared equals a squared plus b squared. So I'm going to end up with a c squared equals a squared, which is 100, plus b squared, which is a 64. So then I have c squared equals 164. And now from here, I just have to take the square root of each side. So I find out that c equals approximately 12.8. So then I put the 12.8 here. I do the 3 plus 12.8, gives me a 15.8. I do the 3 minus the 12.8 gives me a negative 9.8. And now for this one, the transverse axis right here, again, my a squared is 100, so a equals 10. So my transverse axis is 20. Right here, b squared is 64, which means my b value is 8, which means my conjugate axis is 16. And I'm going to rescale this graph a little bit. Looks like the biggest value I have is that 15.8. So I might want to go by 2s or 3s or maybe even 4s on this one. I'm going to go by 3s this time. So I'm going to go by 3s. I think that'll just fit. So negative 4, 3 is going to be right around here somewhere. Negative 4, 13. It's going to be right around here somewhere. Negative 4, 7. Be right around here. Sorry, negative 7. What am I doing? I counted down 7 instead of going down to negative 7. Right here. There we go. Negative 4, negative 7. Negative 4, 15.8. It's going to be right around here. Negative 4, negative 9.8 is going to be right around here somewhere. And so I plot all those values. I can see that this thing is vertical. The transverse axis is 20, and again, I already have that graph. If I count up 20 units, it leaves me at my vertex. And if I count down, 10 units, it leaves me at my vertex. The transverse axis is already graphed, and I should confirm that when I go to plot it. The conjugate axis has to go the other way, so I count to the right 8 and to the left 8. That puts me right around here. And right around here. And now I draw my magic box. It goes through my conjugate and transverse axis. And now I'm going to draw my asymptotes. So I'm going to draw my asymptotes. They go through the corners of the box in the center. And I think I was a little bit off on my on my counting over here. Made this thing look not quite as nice. Should be back here just a little bit. Again, going by 3s, it makes it a little bit more difficult. But we get the general idea here. So we draw these asymptotes. And now from here, again, I start at my vertex, and I hug the line. I start at the other vertex, and I hug the line. So it gives me kind of the width of my curve, and that's it. Okay?